Hello again, everybody. This is Mr. Ward. It is Unit 4 Matrices, Day 6. We're going to do things with what are called inverse matrices. We're going to find them, and we're going to use them to solve systems. So as a quick warm-up, we're going to do matrix A times matrix B. We did matrix multiplication yesterday. We said the middle numbers have to match. That one and that one. The outside numbers give the order. So our answer matrix will be a 2 by 2. We cut the first into rows. We cut the second into columns. And we multiply. Row 1 times column 1, row 1 times column 2, row 2 times column 1, row 2 times column 2. Let's do this. Row 1, column 1, row 1, column 1. Negative 1 times 2 is negative 2, plus move 1 times move 3, 3. Negative 2 plus 3 is positive 1. Row 1, column 2, row 1, negative 1 times 1 is negative 1, plus move 1 times 1 is 1, negative 1 plus 1 is 0. Row 2, column 1, row 2, column 1, 3 times 2 is 6. Negative 2 times negative 3 is negative 6. 6 minus 6 is 0. And then the last one, row 2, column 2, 3 times 1 is 3. Negative 2 times 1 is negative 2. 3 minus 2 is 1. And it wasn't just a coincidence we got that 1, 0, 0, 1. I did that on purpose. And that's going to be called the identity matrix. It's a 2 by 2 identity matrix. The diagonal from top left to bottom right is 1s. Everything else is 0s. A 3 by 3 identity would look like this. And it should look sort of familiar because that's kind of what we talked about with row echelon form and reduced row echelon form. And the idea is we're going to use these inverses that we're going to find to create an identity. Okay? It's kind of like this. The additive inverse of 4 is negative 4. And they add to get 0, the identity element for addition. The multiplicative inverse of 6 is 1/6, and when you multiply them, you get 1, the identity element for multiplication. So the identity element for a matrix is that identity matrix 1, 0, 0, 1. So if you multiply two matrices, a matrix and its inverse together, you should get that identity. That's the definition of what an inverse matrix is. Two matrices that when multiplied gets an identity matrix. And in symbols it looks just like this or like this. The symbol for inverse is the -1 exponent, but you're familiar with that. That should make sense to you. All right. A matrix is invertible, meaning it has an inverse. And only square matrices can be invertible and have an inverse. And if it's not invertible, if it has no inverse, it's called a singular matrix. All right, let's keep moving. Show that A and B are inverses of each other. So I'm going to multiply A times B, and I better get the identity. A we're going to cut into 2 rows. B we're going to cut into 2 columns. I'm going to get a 2 by 2 times a 2 by 2 gives me a 2 by 2. 2 times 3 is 6. 1 times negative 5 is negative 5. 6 minus 5 is 1. So far, so good. 2 times negative 1 is negative 2. 1 times 2 is 2. Negative 2 plus 2 is 0. 5 times 3 is 15. 3 times negative 5 is negative 15. 15 minus 15 is 0. 5 times negative 1 is negative 5. 3 times 2 is 6. Negative 5 plus 6 is 1. Beautiful. What did we just do? We just verified that A and B are inverses of each other. Why? Because when they multiplied each other, they got the identity. And just to show you real quick what I mean by the identity, if you take a matrix, I'll create any matrix I want, 7, 3, -2, 4. And I multiply any matrix by, again, it's got to be square, times the identity matrix. Just like adding 0 or multiplying by 1, it shouldn't change. And if I cut this first one, oh, drop my marker. If I cut this first one into rows, the second one into columns, and what you're going to see is 7 times 1 is 7, 3 times 0 is 0, 7 plus 0 is 7. 7 times 0 is 0. 3 times 1 is 3. 0 plus 3 is 3. Negative 2 times 1 is negative 2 plus 0 is negative 2. 0, 4 times 1 is 4. So if you multiply something by the identity matrix, you get itself. All right, so we know how to verify two matrices or inverses. We know what they get when you multiply them together, the identity. You know what the identity would do to a matrix. Now we got to figure out how to find inverses, because we're going to do something with them in a little while. That is, we're going to solve systems of equations. So here's how you can find inverses. One method called the inverse formula. Very good because we can always follow it, kind of like the quadratic formula. Bad because it's only limited to 2x2s. Okay? And the first thing you're going to be, when given a matrix A, I'm going to call the first term A, the second term B, the third term C, the fourth term D. Here's what you do to find the inverse. 1 over DET. Not quite sure about that yet, but notice this. The A and the D switched. Notice this. The B and the C got negated. So if I do that, that's going to help me find the inverse, but I first got to learn what the determinant is, and the determinant of a matrix is equal to the difference of the cross products. A times D minus B times C. And that goes under a 1. So let's use this formula to find the inverse of this matrix, and we'll verify their inverses by multiplying each other and getting the identity. So, determinant of A, always find it first. 4 times 1 minus 2 times 1. 4 times 1 is 4, 2 times 1 is 2, 4 minus 2 is 2. So A inverse equals 1 over that 2. Switch the A and the D, negate the B and the C. And if I multiply through, a half times 1 is a half. A half times negative 1 is negative a half. A half times negative 2 is negative 1. A half times 4 is 2. That is A inverse. How can I verify that? I should be able to take this matrix, 4, 1, 2, 1, multiply by this matrix, a half, negative a half, negative 1, 2, and I should be able to multiply them together and get the identity. Let's see if that works. 4 times a half is 2. 1 times negative 1 is negative 1. 2 minus 1 is 1. 4 times negative a half is negative 2. 1 times 2 is 2. Negative 2 plus 2 is 0. 2 times a half is 1. 1 times negative 1 is negative 1. Negative 1 plus 1 is 0. 2 times negative a half is negative 1. 1 times 2 is 2. 2 minus 1 is 1. Check. So that is a method of finding the inverse of a matrix. Only with 2x2s, and it's a good formula. Now we're going to actually find it by using our calculator. So we're going to take a look at our calculator, and we're going to find the matrix button. First column, 1, 2, 3, 4, 5 down, right above the x squared, as long as you hit second. So second matrix, there are 3 options. Name is how you access a matrix. Math is how you do some calculations with a matrix, and edit is how you put things in. So I'm going to edit matrix A. So I go over to edit. 1 is highlighted. I hit enter. And A right now is a 2x2. If it wasn't, I would just change it to a 2x2. And there's my numbers. 4, 1, 2. Come on. 1. So now I'm going to second quit. Second matrix A. And I want to find its inverse. And the inverse key is, I'm sure intentionally, the matrix key. A inverse looks just like our symbols. Enter. It's in decimals, but it's the same thing, which is, let's keep it up here, 0.5, 1/2. -1/2, -1, 2, just like we found the other way. All right, let's find the inverse of A here. Let's use the formula method. Step 1, find the determinant of A. A equals 3 times 4 minus 2 times 6. 3 times 4 is 12, minus 2 times 6 is 12. 12 minus 12 is 0. Uh-oh, could that be trouble? A inverse equals 1 over determinant, 1 over 0. It is trouble. What that means, take a guess. The answer is, if the determinant of a matrix is 0, that means A is singular. There is no inverse. What does the calculator do? I don't know. Let's check it out. See what happens. So let's go second matrix. Over to edit. Down to 2. B is right now a 3 by 1. I want to change it to a 2 by 2. 2 enter, 2 enter. Here's our 4 boxes. 3, 6, 2, 4. There's our matrix. Second quit. Clear. Second matrix. B, I want to go down to 2 and access it. Hit enter. 3, 6, 2, 4. Got it. Second matrix. B. Enter. Inverse. Let's see what happens. Singular matrix. No inverse exists. Calculator supports our algebra work. Beautiful. All right. Why are we finding these inverses, Mr. Ward? Here's why. Because if I have an equation, A times X equals B, and I said solve that for X, you would say, Mr. Ward, move that A over, divide it off. Well, you can't really divide it off. What you're going to do is you're going to multiply by A inverse, because then that will take these two and cancel them to the identity. But if you do it there, you have to do it here, which means to solve for what I'll call the variable matrix, you're going to take the answer matrix, that's B, and multiply it by the inverse of the coefficient matrix. Lots of new terms, but that's a valuable statement right there. If A times X equals B, then X equals B times A inverse. Sorry about that. Actually, that's not correct. I believe it's got to be this way. All right. It probably doesn't matter, but that's okay. I like to write it that way anyways. All right. So we got about 2 more minutes. Here's the first thing we're going to do. We're going to set it up in not augmented, but rather 3 matrices. A coefficients, a variables, and an answer. So the coefficients, 3, 4, 5, 3. The variables, x, y. The answers, -2, 4. Just like always, we're solving for x, y. What does that mean? We're going to have to find A inverse. Again, let's call this A. Let's call this X. Let's call this B. We're going to have to find the inverse of A, and we're going to multiply it by B. See if I can, got about a minute left, see if I can scoot real quick and find it. The inverse of A I found on my calculator to be -3 elevenths, 4 elevenths, 5 elevenths, -3 elevenths, and that's what's going to get multiplied by B. I will pick this up on a second video in a couple minutes, right where we left off. All right, very good, guys.